आज की क्लास में हम पढ़ेंगे Curtius rearrangement reactions, which is the one of the most important method for the preparation of amine from azide compound or from acid chloride. मैं गंगानी सर आपका स्वागत करता हूं. Let's start Curtius rearrangement reactions. Now, suppose we have an acid chloride. Now this acid chloride is allowed to react with sodium azide NaN3. When we hit, then sodium chloride will remove and we are getting this type of structure, RC double bond O and here N3. Now whatever the structure obtained, it is known as a acyl azide. This much part is acyl and this part is considered as a azide. Now this acyl azide is unstable, so when we hit little it, then nitrogen gas will liberate, which is the one of the best leaving group. When nitrogen gas liberate, then we are getting a isocyanate. Now whatever structure obtained, it is isocyanate will be obtained. Now whatever isocyanate obtained to us, this isocyanate further undergo hydrolysis in the presence of water. When it undergo hydrolysis in the presence of water, carbon dioxide will remove and we will get primary amine. So it is observed that primary amine can be prepared from acyl chloride. So the basic concept you have to put in your mind that acyl chloride or acyl azide is converting in a primary amine, which has a one carbon atom less as compared to acid chloride. So we can write these things. What is the basic thing that by using this method, we can say that acid chloride or azide, or we can say acyl azide. This acid chloride or acid azide can be converted into primary amine, and this whatever primary amine obtained have a one carbon atom less. This is the basic thing of this reaction. Now, question will arise, how this acyl chloride is converting into azide converting into isocyanate, and how we are getting primary amine. Then you should focus on mechanism. यदि आप mechanism जानते हो तो कोई भी questions IIT का हो, JAM का हो, NEET का हो, you can solve very easily. So focus on this mechanism. Now, in the very first step, this acyl chloride, when allowed to react with acyl azide, then we get this azide structures. Now whatever azide obtained, it has this type of structure. When acyl chloride reacting with sodium azide, then we get acyl azide. Now whatever acyl azide obtained to us, it has a resonating structure. So we can write this structure in this way, RC double bond O, then this nitrogen having a double bonded with this nitrogen. Now this nitrogen having a one valency less, so it has a one electron pair and negative charge. This nitrogen having a one valency more, so it has a positive charge and no electron pair. And this nitrogen having a three bond and one electron pair, so nothing charge on it. You know that nitrogen having a one non-bonding electron pair and three bond. So here you can observe that nitrogen with one electron pair and three bonds. This nitrogen having a one more bond, so it has a positive charge, no electron pair. This nitrogen having a one less bond as compared to three bond, so it is a negative charge and electron pair. Now this compound is unstable, so it is a resonance, and during this resonating structures, this nitrogen give electron pair to this nitrogen and this bond will transfer on these structures. So we can write a structure in this way, RC double bond O. Now this nitrogen have given electron pair to bond formations, so we can write these things. This nitrogen give electron pair to this nitrogen, so we can write this. Now this nitrogen having a triple bonds, so it is a triple bond, so it has only one electron pair. Now this nitrogen having a negative charge because this nitrogen having a positive charge because one bond is more, and now this nitrogen having a electron pair and negative charge. So now it is observed that this is a totally resonating structure. This electron pair transfer to this nitrogen, so triple bond form between these nitrogens. So now this electron pair transfer on this nitrogen. When transfer on nitrogen having a two non-bonding electron pair and negative charge. Now it is observed that this is a totally unstable structure. So in the first step of mechanism, in a step 1, when we hit these structures, then on hitting of this structure, nitrogen will remove. Here, this bond will break. When this bond will break, nitrogen gas will remove. It is the best living group of world. Now, as a result, we will get this structure RC double bond O. Now, this nitrogen having this electron pair gone. So, nitrogen having no charge and 2 electron pair. And with this we are getting a nitrogen gas. Now whatever structure obtained, it is nothing but it is known as a nitrene. So in a step 1, formation of nitrene occurs. We can write it in a step 1, formation of nitrene occur. Now nitrene is unstable in nature, so in step 2, nitrene will converted into isocyanate. So we can write step 2, formation of isocyanate. For second step, formation of isocyanate. Now this alkyl group, nitrogen having 3 bonds, but it is, you observe that here only 1 bond. So this nitrogen give electron pair to carbon, then this bond will break, this alkyl with electron pair transfer on nitrogens. So this nitrene is unstable in nature, so it's converting in a isocyanate. This alkyl group with electron transfer on nitrogen. We can write structure in this way. Now double bond between carbon and nitrogen. Nitrogen will give an electron pair to carbon, so double bond between nitrogen and carbon. Alkyl group transfer on nitrogens. So whatever structure obtained, it is considered or known as a isocyanate. Now in the next step of mechanism, isocyanate undergo hydrolysis. Next step of mechanism is formation of carbamic acid. Now this isocyanate undergo hydrolysis and converting in a carbamic acid. We can write in this way, R and double bond C double bond O. So here I will combine these 2 steps. In the presence of aqueous solutions, it is observed that this will disproportionate. Now this pi bond electron, here 1 sigma and second is pi bond. This pi bond electron will transfer on hydrogens. So now here this hydroxyl group attack on this carbon. When hydroxyl group attack on this carbon nitrogen bond will break. When this carbon nitrogen bond will break, this electron pair of pi bond will transfer on nitrogen, and nitrogen give electron pair to hydrogen. So now we get this type of structure. This is a R and nitrogen having a hydrogens, and here carbon having a double bond with oxygen, and here hydroxyl group. So now whatever structure obtained to us, it is known as a carbamic acid. Okay. In Hoffman rearrangement reaction also we have studied in detail. यदि आपने मेरा वो वीडियो नहीं देखा तो देखिए, उसमें डिटेल से 3-4 स्टेप और है, 3 स्टेप और है, उसमें मैंने डिटेल में बताया कि किस तरह से isocyanate का हाइड्रोलिसिस होता है. Now in the same step I will put this further, that here further whatever hydroxyl group we have, this hydroxyl group, now loss of carbon dioxide or decarboxylation of carbon, we can write the step 4, the decarboxylation of carbamic acid. Decarboxylation of carbamic acid. Decarboxylation of carbamic acid, and as a result we will get a primary amine. Now here this hydroxyl group we have in a solution, so this hydroxyl group in aqueous solution will attack on hydrogen, it remove in the form of water. Now this electron pair transfer on oxygens, so this carbon oxygen double bond form, and here electron pair transfer on nitrogen. So we can write the structure in this way, that here R N H, here carbon having a double bond with oxygen, here oxygen with this hydrogen. Once again I would like to repeat, hydroxyl group attack on this hydrogen, so it will remove in the form of water molecule. Now this bond electron transfer on oxygen, and oxygen give electron to carbon. this carbon or nitrogen bond will break and this electron will transfer on nitrogen. So we get this structure R, nitrogen having a hydrogen with negative charge. And here carbon dioxide gas will release, and with this we are getting a water molecule. Now in next step, this nitrogen give electron pair to water and we get a primary amine. Now in further, in a next step, this water molecule I can write in this way, H and OH. Now nitrogen give electron pair to hydrogen, this electron pair transfer on oxygen, and as a result we will get a primary amine, and with this we are getting a hydroxyl group. So now students, in this four step, acyl azide is converting in a primary amine, and whatever primary amine obtained to us, it has a one carbon atom less. So चलो एक बार रिवाइज कर लेते हैं किस तरह से हुआ. Very simple thing, acyl chloride when reacting with a sodium azide, it gives a acyl azide. Now this acyl azide has this type of resonating structures. Now this central nitrogen having a 4 bond, this nitrogen having a 3 bond. So one electron pair, now it has a 4 bond, so electron pair given, so positive charge. This nitrogen having a 1 bond less, so it is a negative charge. Now this is the resonating structure. Now when we hit this resonant compound, then nitrogen gas will remove and it is converting in a nitrine. So in step 1, formation of nitrine will occur. Now whatever nitrine obtained to us, it is converting in a isocyanate. Nitrine is highly unstable, so nitrogen give electron pair to carbon, it is a 2 electron pair, so it form a bond with a carbon. At the same time, this bond will break, alkyl will transfer with electron on nitrogen. So as a result we get this structure which is known as a isocyanate. Now this isocyanate undergo hydrolysis and form a carbamic acid. This structure RNHCOOH is known as a carbamic acid. So we have aqueous solutions. In aqueous solutions, hydroxyl group of aqueous solution will attack on a carbon. So this pi bond will break. Now pi bond electron transfer on nitrogen, nitrogen give electron pair to hydrogen. So we are getting that hydrogen attached with nitrogen and hydroxyl group attached with a carbon. And as a result we get carbamic acid. Now this carbamic acid undergo decarboxylations. This hydroxyl group attack on hydrogen, it removed in the form of water. Now this electron transfer on oxygen and oxygen give electron pair to carbon. So double bond will form between carbon and oxygen. At the same time this carbon nitrogen bond will break, electron pair transfer on nitrogen, it is converting in a negatively charged species. Now carbon dioxide remove and we are getting a water molecules. Now this negatively charged species nucleophile will undergo protonation with a water and give primary amine. So now the basic funda of Curtius reaction or Curtius rearrangement reactions, we will get a primary amine from either acyl chloride or from acyl azide, but the most important thing, it has a one carbon atom less as compared to acyl azide or acyl chloride. Now we will study what are the different applications of this Curtius rearrangement reaction.